All right. So we were talking about launching with angles. You guys already did. We did talk about this conceptually a little bit. Now we're going to talk about how to do some of the mathematical stuff here, right? So our instructions are pretty much the same as they have been with all 2D kinematics problems, right? Plus and minus directions, split into x and y values, using triangles and trig if necessary. Ax equals 0 and ay is negative 9.8, right? Because these are projectiles. Do 1D kinematics in one dimension and use that info to solve for the other dimension generally. And then you're going to recombine into a new triangle. I should probably say if necessary. So I've got 3 examples to go through for this, and they're going to use angles in different ways. Okay, so and that's going to be pretty much evident in the homework. So you're going to use the angles in different ways. So the first one, we shoot a Nerf gun at an angle of 30 degrees above the horizontal at 15 meters per second. If the gun is 1.5 meters above the ground, how far horizontally does it fly? Okay. So we always want to start with, right, we got our little table of values. Y, final Y, AY. And we know, right, that these two are zero. I guess we should have said that up is positive Y. We'll say to the right is positive X. I guess we should have that first. But we got this. Okay. The only other piece of information we have that's not a triangle is this 1.5 meters above the ground. So if it starts 1.5 meters above the ground, that's where the gun is, then that means that it hits the ground, it's going to be negative 1.5 meters. It's going to have fallen 1.5 meters. Next thing we can do is we can draw this triangle. So we got to shoot a Nerf gun. That must mean the Nerf gun is, this must mean the initial velocity. So we've got our little triangle here, where we've got 30 degrees and 15 meters per second on the hypotenuse. And on the sides of this, right, we got v initial x and v initial y. We can use trig then to find those two values. So v initial x over 15 equals cosine of 30, and v initial y over 15 equals sine of 30. V initial y is going to be 7.5, and v initial x is going to be 13. So v initial y 7.5, v initial x is 13. Okay. All right. I want to find how far horizontally does it fly, right? I guess I should have said that we're trying to find this value here. Notice I do not have enough x values. I only have 2 known x values to find the change in x. So I'm going to have to find time with my y values. And the good news is I have 3 of them there. Now I could go straight to it. I could say, use the equation, change in y equals v initial y times time plus 1/2 ay times time squared. But if I do that, I'm going to get that quadratic. And I have to use a quadratic formula or something else. So I'm not going to do that. I'm going to go ahead and try v final y squared equals v initial y squared plus 2ay change in y. I'm going to use that one instead. I've got v final y squared equals 7.5 squared minus or plus 2 times negative 9.8 times negative 1.5. Okay. If I do that, I get v final. If I plug everything in there, v final is negative 9.25. And once I have that, it's easy to find time using v final y equals v initial y plus at. Going back here, remember your calculator, you're taking the square root, is going to give you a positive number. But remember, we know that the final velocity, right, it's going down. It has to be landing. If it's hitting the ground, right, the dart has to be moving downward when it hits. So hopefully that will be pretty obvious to you. Okay, this is negative 9.25 equals 7.5 minus 9.8 times t. That should be ay. And I get time is equal to 1.71 seconds. If time is 1.71 seconds, now I have that third value in the x direction, and I can do change in x equals v initial x times time plus 1 half, and this whole other thing is 0, right? This 1 half at squared is 0. So I get that it goes 22.2 meters in the air. Okay, so in this case, right, the only thing I had to do was I had to do the angle part first. Split it into x and y. The only step. This one should be pretty straightforward for you because it is relatively, like, you know, it's similar to the 2D kinematics problems with angles. You just do an angle thing first and you're good. Okay? All right. Now we've got a rock is thrown horizontally at 10 meters per second off a 20 meter tall cliff, and I want to know what the magnitude and direction of the impact velocity is. Okay? So, right, up, positive y, to the right, positive x, right? So then we have change in x, change in y, v initial x. I probably should just have a way of copying this every time, but I don't. If I'm smart, I'm going to copy it right as I finish to the next page. I'm going to go ahead and do that, so apologies. There we go. That way I won't have to do it next time. Alright. So, what do I know? Well, I still know that AX is 0. I still know that AY is negative 9.8. The rock thrown horizontally. That should tell us this is a 0 launch problem. That means this is 0. V initial y is 0. And that means that all of this 10 meters per second, that's Lx. And a 20 meter tall cliff, this is negative 20 meters, right? If you start, right, if the object's being thrown from up on this cliff, it's actually being thrown horizontally and down, right? This is my change in y, and it's got to be negative. Okay, I want to know the magnitude and direction of the impact velocity. So impact velocity, right, is that v final. So I need the v final for both of these, for both x and y. V final x is easy. Acceleration 0, v initial and v final are the same. V final y I can find, right, with v final y squared equals v initial y squared plus 2a change, or 2ay change in y. Okay. So I've got v final y squared equals 0 plus 2 times negative 9.8 times negative 20. When I do that, this is v final y is equal to negative, or no, that's just equal to 392. And v final y is equal to negative 19.8. Okay, it's got to be negative again because it's down. All right, so I've got the two v finals. I actually don't need to find time this time. Okay, but I've got my v finals. So I've got v final x. Right, I can make my little v final triangle. V final y. Negative 19.8. And v final x, which is 10. And now I'm looking for this hypotenuse and this theta. So for the hypotenuse, right, I can do the Pythagorean theorem. So that's going to be v final squared equals v final x squared plus v final y squared. And I can't emphasize this enough. This is 10 squared. This is plus, and we're going to square the whole 19.8 squared, right? That negative sign is going to lose it. We're going to lose that negative sign, I guess. The negative sign is not going to lose it. If we do this, we get that this is 22.2 meters per second for v final. For the angle, right, we can use an inverse tangent. So tangent, could use inverse sine or cosine here, but tangent inverse of well, let's start over a little bit. Let's start a step further back than that. Oops. We know that tangent of theta is equal to v final y over v final x. That means that in theta is equal to inverse tangent of v final y over v final x. And if we do that, we should get that theta is equal to 63.3 degrees. And that is below the horizontal. And it's called that because, right, we went horizontal, then below. So below the horizontal is how we describe that. One more example, guys. A ball is thrown horizontally from 2 meters off the ground, okay, and hits the ground at an angle at 20 degrees below the horizontal. What is the initial velocity? So 2 meters off the ground, -2. We know AX is 0, AY is -9.8. It's thrown horizontally. So V initial Y is 0, not negative anything. And I want to know what the initial velocity is. Okay? So, well, I have this thing. The one thing I haven't used, I haven't used this. This 20 degrees below the horizontal. Hits the ground. Hitting the ground implies like that impact. And the best way to describe impact is V final. So I have this triangle I can make. Or this is 20 degrees. And this is V final X, V final Y, V final. So I don't have any of those sides though. But I'm looking here and I actually have 3 of the values for Y, which means I can find that third side. So V final Y squared equals V initial Y squared plus 2A, AY change in Y. Right, so this is V final Y squared is equal to 2 times -9.8 times -2, which is 39.2. And I can find that V final Y is equal to -6.26 meters. Again, meters per second. Again, notice the negative sign. The negative sign is there because I know it's going down. Now I have one of the sides to this triangle. This is equal to 6.26 down, right? And I can all of a sudden use trig to get V final X. So I've got tangent 20 degrees is equal to 6.26 over V final X. So that means that V final X is equal to 6.26 over tangent of 20, which comes out to be 17.3 meters per second. Now normally I would need to have a third value. I could solve for time with Y, so I could order to get V initial X. But I actually don't need to this time. Okay? I actually, because the acceleration is 0, these two values are the same. So I actually just know this is 17.3. So V initial X, 17.3. And I don't need to know what then that means that V initial is 17.3, right? Because V initial Y is 0. So that's my answer. Okay, you can do problems like this. If you're given one side of a triangle or the angle of the triangle, you can always try and solve for a second side with X or Y and use that as a additional value in order to use the triangle. All right. So bottom line of these problems, more triangles involved. They might be involved at the beginning. They could be involved at the end. Like, so here, this problem, the triangle was at the very beginning. In this problem, the triangle was at the end, right? We made the triangle at the end. We had to find the direction of impact. And here, the triangle was actually in the middle. It was like the connecting step between Y and X. All right, so those are the three ways triangles will be used in this. And just, I guess we'll practice and we'll see how it goes.